morning. Welcome back for that same chapter, that is Boolean logic. And today we will go for the logical operation. In the last class I told you about what is logic and how the logical operations are performed in computer. Okay. So just have a recap of that session. The logical operation or the logic is nothing than a condition which answer can be yes or no, and which is represented in computer as zeros and one. That means yes as one and no as zero, or true as ones and false as zero. So in case of logical operation, in the last class I told you there are three kind of operators. So one is the AND operator, another is OR operator, and the third one is the NOT operator. So today we'll learn how the AND operator, OR operator and the NOT operator are working. But before learning about this operator, we should know two or three things. The first thing is a binary quantity or value. The binary quantity or value is nothing than the value that is 0 or 1 or true or false. As you know, the binary digit means either it could be a 0 or a 1. But in case of logical operation, these zeros and ones are represented as false and true. So these two values are known as binary quantity or binary value. The second thing is a binary variable. Now variable is a named identifier that identifies a value. Any value that is identified with any kind of name, that name is known as a variable, and which value can be varied or changed. That's why this is known as a variable. Which value can be changed, that is known as variable. So in normal mathematics you might have learned about x, y, z. These are the different kind of variable. In mathematics you learn about single variable, double variable equations. Okay. So actual what happened there, the variable represent a value. The variable itself not a value, it represent a value. So here the same concept has been used. The binary variable are those variables which represent the value either a 0 or a 1. Because the binary values only zeros and 1. So that the value or the variable which value ranges in 1 or 0, that is known as a binary variable. So binary quantity, true or false, 0 or 1. Binary variable, a variable whose value ranges in zeros and ones. Okay. The third thing is a truth table. Now this is the different kind of truth table. Now truth table is a table that combines all possible inputs of a particular operation. In the last session I told you about two different conditions. You want to drink tea, the tea is prepared. So if you are combine these two situations, then we have the answer either both are true, or the first true, second false, the first false, second true, or both are false. So these are the different kind of values or different combination of values, and total we have only 4 combinations of values in case of two conditions. So the truth table is a table that contains different combination or all possible combination of input and its respected output. That means whatever be the value or whatever be the value can be operated through a operator, that combination of values and its respective outputs or whatever result we are getting from that value. The combination of that input and output is known as a truth table. And the operator is represented in with a diagram. That diagram is known as a Venn diagram. In case of a Venn diagram, it just shows what is the variable and what part of that variable is shown as output, or what part of or what amount of value from that variable can be shown in a output. Okay, so these are the 4 things you have to remember. First one is the binary quantity and value. Second is the binary variable. third is the truth table, and fourth is the your Venn diagram. Okay. Now after that, when we are talking about the truth table, so we have two kind of result appear in a truth table. As we are entering in a truth table, or the input of a truth table is always zeros and ones. So accordingly that the output should be zeros and ones, nothing else than zeros and ones. Okay, if you are talking about binary operation or binary digit or binary calculation, then everything will get and enter and calculated through zeros and one also. So the output and input of a binary operator or a truth table is always either 0 or a 1. Okay. Now some of the truth table are there which output is always 1, and some of the truth tables are there which output is always 0. Now such a table which output is always 1 is known as a tautology. It is known as tautology. It is known as tautology. And if the output of a table is always comes in term of false, then it is known as falsy. Tautology and falsy are the two kind of truth table. The truth table whose output is always 1, that is known as a tautology, and the output of the table which is always 0, that is known as falsy. Now come to our topic, that is the logical operation. And in case of logical operation, we have only three kind of operator for logical calculation. One is the AND operator, OR operator, and the NOT operator. Now come to the AND operator. The AND operator is represented by a dot. Okay, the AND operator is represented by a dot. So if both the input are A and B, then the output should be A dot B. If I is the input, B is the input, then the output of AND operator or the result of AND operator is A dot B. Now look at the truth table. What happened here? If the A is 0, that means A false and B false. A 0, B 0, then the output is 0. If A 0, B 1, then also output is 0. If A 1, B 0, then also the output is 0. If both the outputs are 1, then only will get the output. If both the inputs are 1, then only will get the output as 0. As I told you in the last class, in the last session, you might have remembered that the two conditions are there. You want to drink tea and the tea is prepared. If both the conditions are true, then only will get a true result. That means if you want to drink a tea, yes, you want to drink tea, but the tea is not prepared, then you cannot drink the tea. Suppose you don't want to drink the tea, but still the tea is prepared, then also you won't drink tea. If you don't want to drink tea, even the tea is not prepared, then also you don't want, you cannot take your tea. If both the conditions are true, that means if you want to drink a tea, yes, and the tea is prepared, yes, then only you can drink the tea. So that is AND operator, where both the conditions are true, then only will have a true result, otherwise I will have a false result. Now this is the Venn diagram that represents the AND operator. This is the variable A, this is variable B, and this part what intersect both A and B, that part is represented as A dot B. The part that intersect both A and B, that part is known as your A dot B. Now this is all about AND operator. Now come to the OR operator, which is represented by false. And here, if any one of the condition is true, then we'll have a true result. In the last session, I told you about two situations. One is the math is very easy, or I should use a calculator. The math is easy, then you can solve the math. Otherwise, if you are using calculator, then also you can solve the math. So if any one condition out of the two conditions are satisfying or two conditions are true, then we are getting the true result over here. So here the truth table is only a single case where both the inputs are false, then only we'll have a false result, otherwise we'll have a true result. That means 0, 0 will get 0, otherwise 0, 1, 1, 1, 0, 1, 1, 1 is also 1. So if any of condition or any one of the condition is satisfying or true, then we'll get the true result over here. Now the Venn diagram is like this. The total A and B, that is represented as A plus B. This is set A, this is set B, or this is variable A, or this is variable B. Now the total A and B, the combination of A and B, the whole section is known as your A plus B. Okay. Now come to the third operator, that is the NOT operator. Unlike AND operator and OR operator, the NOT operator is executed or processed over a single value, and it used to negative or used to make negative of a value, or it used to complement a value, or it used to change or reverse a value. That is the NOT operator. Reversing the value in the sense, if we are passing 1, then we'll get 0. How? Using a NOT operator, you can simply change the meaning of a statement exactly its opposite. Exactly its opposite. You like tea. If I'm using a NOT operator, then what happens? The total meaning has been changed to its exactly opposite meaning. You are not like tea. The meaning is completely changed or completely reserved. That means whatever be the value, if it is true by using the NOT operator, it becomes false. And by using if it is false by using the NOT operator, we can create it as a true condition. So here what happens, if the input is false, then we'll get true. If the input is true, then we'll get false. And it is represented by dash or bar. You can use either a bar, or you can use either a dash for representing. So in case of Venn diagram, if it is the value A or it is the set A, then remaining part of that value is known as your A dash, or it is A bar. If this part is A and A, then the remaining part is your either known as A bar or A dash. Because this complete set E, suppose this is a set E, this set is represent nothing than two values, that is 1 or 0. When you learn about set theory, you will get through all that thing. So E is equal to either 1 or a 0, because two values are there. And if I am taking A as 1, then the remaining part is 0. If I am taking A as 0, then the remaining part is 1. So these are the three variables. These are the three operators that use for logical calculation. And before remembering or before going for this logical operation, you should know about the four things. That is, what is binary quantity, what is binary variable, and what is truth table, and what are falsy, and what are tautology. So this much for today. Thank you. And if you have any kind of problem, or if you are not able to understand, feel free to contact me. Okay, you know my number, so please contact me on that number if you have any kind of problem. Thank you and have a nice day.